In this video, we're going to look at determining the derivative of the given function by using the limit definition of a derivative. We've already done two examples in two different videos where we talked about the derivative and its relationship to slope. So in this one, I'm just going to jump right in and work through the derivative. So the first thing I'm going to do is I need f of x plus h. So I'm going to calculate f of x plus h, which that's the square root of the quantity 2, and I'm plugging x plus h in just for x, so that's 2 times x plus h. So once I have that, then I can set this up using my original function and the f of x plus h that I have here. One note, and it's really up to you, but you can go ahead and distribute that 2, and you can say, well, that's 2x plus 2h. So I'm going to write this out, my derivative, and you need to write f prime of x. So f prime of x is equal to the limit as h approaches 0 of f of x plus h, which we just found, which is the square root of 2x plus 2h, minus the original function, which is the square root of 2x. All of this is divided by h. If you can get here, I know that you understand how to set this up. So pause, take a moment, make sure you understand what we're looking at. We have the function with x plus h plugged in for x. We have the original function all divided by h. The limit as h, as the horizontal distance between our 2 points approaches 0. And then you do need to write the derivative equals. You need to write it at least once. And then as you work through the problem, you can just continue to write equals. So this is equal to the limit as h approaches 0. Now, we need to figure out how to manipulate this. The issue is we have this h in the denominator and we don't want it there because when I evaluate limits, I try to plug in h, and here I can't plug in 0 for h because that would give me a 0 in the denominator. So I'm going to use a trick. What I'm going to do is I'm going to multiply this expression by a value. And the only value I'm allowed to multiply by is 1. So I'm going to put whatever I decide to multiply by over itself, because anything over itself is equal to 1. So looking at this, I'm going to use what's called the conjugate. So I'm going to say 2x plus 2h and the square root of 2x. And since I was given a problem with a minus in between it, now I'm going to put a plus. That's the conjugate. And if I put anything over itself, it's equal to 1. So right here in light gray, what I've written, I'm multiplying by 1. So now I'm going to FOIL my numerator, and I'm going to leave my denominator in factored form. We almost always leave the denominator in factored form. FOILing my numerator, my first, square root of 2x plus 2h times itself, that is it squared. So I have 2x plus 2h. Now the genius part of the conjugate is that my inner and outer terms, those are identical, but they differ in sign. So they're going to cancel each other out. I don't need to write those. And then my last terms, square root of 2x times square root of 2x, that is square root of 2x squared. And the square and the square root cancel it out, so I just have 2x. And because it was negative times positive, I have a minus in there. So all of that is over h times the quantity square root of 2x plus 2h plus the square root of 2x. So that's the big trick. Now, FOILing this should be easy, but if you do need to write out your 4 terms or maybe use the box method to help you organize, however you can get this multiplied, you need to be able to do that successfully. And you've taken algebra, so That's really just an algebra problem. All right, so what does that leave me with in the numerator? Well, 2x minus 2x will cancel. I now have, don't forget to rewrite your limit. The limit as h approaches 0 of 2h over h times the product we have here is 2x plus 2h under the square root plus the square root of 2x. You'll notice h over h cancels to 1. And now I've canceled that h in the denominator. So I have the limit as h approaches 0 of 2 over the square root of 2x plus 2h plus the square root of 2x. At this point, once I have canceled that h value, I'm going to take the 0 in and plug that into my function for h. I no longer need to write limit, so this is the square root of 2x plus 2 times 0 plus the square root of 2x. So that's going to cancel right there. We have 2 over the square root of 2x plus the square root of 2x, or 2 over 2 square roots of 2x. 2 over 2 cancels, and I'm left with 1 over the square root of 2x. So that means my derivative, f prime of x, is 1 over the square root of 2x. That's how we find the derivative. If you have any questions, please feel free to get in touch with me. Thanks, and have a good day.